All right, let's back off. This is distance formula back and forth. This is midpoint formula back and forth. Now, the next thing that's coming here, let's do the gradient. The gradient, they use the small letter m. You want the gradient, maybe say, of line AB. But A, M, B are on the same straight line. That means I can also find the gradient, it must be the same as the gradient of capital letter MB. Can you see MB or AM? It's the same thing as gradient of A capital letter M. Why? These are the points on the same line. So to get the gradient, you just use any 2 points. So in this case, it will be given as y2 minus the y1. That's the gradient. And then divided by x2 and then minus the x1. Now, remember the stuff you wrote up and said. It was to help you not to make mistake. I'll substitute. So if you want to do the gradient using A and M, that means maybe the M becomes x2 and y2. The choice is how you want to put it. All right, so let's show the gradient. Now, the gradient, that means in this case, we are going to say, I'm still using the previous values. Y2, get 12. So it's 12 minus y1. So it's going to be 12 minus from the formula, minus what? And negative, minus negative 8. So it's about plus now. It's a plus because it's minus minus. Then x2, it's 6 minus the 2. So it's going to be 6 minus the 2. And then when we work out all of that, at the top, I think we're having 20. At the bottom, 4. 20 divided by 4, it's 5, isn't it?
Yeah.
That's the gradient. But it is the same. You could have worked it out this way and say the gradient of capital letter AM. So it's going to be the same. So you're still using y2 minus y1. So that means you are not using that one. So that means this one now becomes your x2 and your y2 because I'm keeping this as x1 and y1. So the gradient must be the same. That's the thing I spoke about collinear. So that means I'm going to take y2, which is 2 there, minus y1, meaning minus 8. So it's going to be plus the 8. And then divided by x2, it's 4 minus 2. So it's 4 minus 2. Let's double check it. 8 plus 2, it's 10. 4 minus that is 2. 10 divided by 2, you still get a 5. Same gradient. Then I could have done the gradient. It's the same line. You don't have to do it many. You do it at once. Of MB. Capital letter MB. So y2, well, since I can delete it again. If I'm calling this y2, this I can ignore. And so, okay, this is my x1, this is my y1. It doesn't make any difference. So x2, y2 get 2, so it's 2 minus the 12. So I'm having 2 minus the 12. And then I'm going to divide that by 4 minus the 6. 4 minus the 6. And then at the top, I'm having a negative 10. At the bottom, I'm having a negative 2, which gives me a positive 5. Can you see the gradient is the same? Can you see that? Good. The reverse form, let's use one of them. Let's say, for example, they didn't give you AB. Let's use AB. Let's say I was not given, maybe let's say that the 2 was not given. Let's say the 2 was not given. It was a known letter. Maybe say, let's just say they call it small letter r. They say find small letter r, but gradient they told you ke 5. But you could have worked it out, got these 2 points or ke 5. So which means you are going to put 5 here by the gradient. And then by y2, because this was your y2, it's about 12, x1 ke 8, I mean y1, x2 ke 12, and then the x1 ke r. Then at the bottom, nonally r, nonally r, and everything valent no equator to 5. So where now you are going to say 12 plus that 8, get 20. So you are going to have 20 at the top divided by 6 minus the r equals to 5. Mathematically, this one must come and multiply more. So you've got 20 equals to 5 into 6 minus the r. Well, there is no need for me to multiply inside. I can go very sharp by dividing by 5 more, dividing by 5 there one time. Then I've got 4 equals to 6 minus r. Kitli says 6 kamo. So it's actually 4 minus 6. 4 minus 6 is minus 2 equals to minus r. Change the sign. 2 is r, like how we had it, r was 2. Can you see that? Good. That is how to deal with the gradient back and forth.
Okay.
Now, if you've got 2 lines which are parallel to each other, I'm just putting another one, but I'm making a mess there. That's right at the top. 2 lines which are parallel to each other, their gradient must be equal. You know that, right? Okay, let me write it like this. So I'm just going to put that line there and put another line there. I'll call the first one line 1. I'll call this one line 2. So line 1, the gradient of line 1, I'll call it M1. The gradient of line 2, I call it M2. Then I'm putting the arrows to show that they are parallel. So I can say if line 1 is parallel to line 2, then the gradient of line 1 equals to the gradient of line 2. You good, right? Right. Then let's talk about something else, perpendicular lines. So I've got that line, and then I'm going to have another one which makes 90 degrees. All right, so it makes 90 degrees. Let me shift it there. Then I put a little box to tell you it's 90 degrees. Let's call the blue one line, let's call it line 1 with the gradient M1. I'm going to give it the value. Let's make it negative 2 over the 3. I'm just making an answer. Because that's the previous one, if the gradient here was 2, this one will also be 2. You know what I'm saying? All right.
Yes.
Then we've got this one as line number 2. It has a gradient of M2. Now we write, if line 1 is perpendicular to line 2, for you guys, they told you then when I take gradient of line 1 and times it by gradient of line 2, I must get minus 1. Am I right?
Yes.
Well, I don't like that. I like this one. The gradient of line 1 must be equals to gradient of line 2 upside down, meaning I take the other gradient, put it upside down, and change the sign. You understand what I'm saying? So this
Yeah.
one is better, but it looks crazy the way it's written, but I don't have to write it that way. Let me show you what I mean. Here, what we've got, Runa, we've got line 1. It has a gradient of -2/3. So therefore, the gradient of line 2, it's a shortcut of saying this. You don't need this. This one goes crazy. So what you do, you take that gradient, write it. You do two things. Two things must happen. Write it upside down. It now becomes 3/2. And then change the sign. It was negative, you make it positive. So when you multiply that and that, utotola -1. That's how quick it is.
Okay.
We're good, right? These are lines which are perpendicular to each other. All right.
Okay.
So I'm done with the gradient, but I'm gonna come back and include it leading to the line of inclination.